Hello, this is the lecture number 4 for the chapter sets of class 11th, and we were discussing the last lecture, the exercise 1.1, and we have done up to question number 4. Now in question number 5, the set builder form of a set is given and you have to convert into the roster form. So what is given in question number 5? First part, it is x such that x is an odd number. So simply you have to write the odd numbers, that is 1, 3, 5, 7 and so on. It is an infinite set. In set B, it is x such that x belongs to integer which is greater than minus half and less than 9 upon 2, that is greater than minus 0.5 and less than 4.5. So integers greater than minus 0.5 is 0, 1, 2, 3, 4, which is less than 4.5. Now you have to find in set C those integers whose square is less than equal to 4. Those integers whose square is less than equal to 4. So the square of 2 is equal to 4. The square of minus 2 is equal to 4. We can take it. The square of 1 is less than 4. The square of minus 1 is less than 4. The square of 0 is less than 4. So these are the 5 elements of this set. In fourth part of this question, x such that x is the letter of the word loyal. So L, comma O, comma Y, comma A are the elements, because L is repeating 2 times. So I have to write only one element only once in a set. X such that x is a months not having 31 days. So you have to write those months which does not have 31 days. So those months are February, April, June, September, November and so on. F is a set such that x is a consonants preceding the alphabet K. So you have to write consonants before the letter K. So A is a vowel. So B, C, D, F, G, H are the consonants of before the letter K starts. So these are the questions of exercise 1.1 which we have discussed. In question number 6 of this exercise, in the left hand side the roster form is given, and on the right hand side the set builder form is given. So you can easily match the column 1, 2, 3, 6 is the natural number and a divisor of 6, which is the C part. 2, 3 is the prime divisor of 6, prime number, the divisor of 6, that is this part. These are the letter of the word mathematics. So this is with this. The 1, 3, 5, 7, 9 are the odd natural number less than 10. So these are the question number 6 of exercise 1.1. In exercise 1.2 is also very easy. You have to, in question number 1 of 1.2, which of the following are the example of the null set? You know that the null set is an empty set, the set which does not have any element. So set of odd natural number divisible by 2. So you have to write odd number divisible by 2. So there is no element which is odd number which is divisible by 2. So it is a empty set or a null set. Set of even prime number. So set of even prime number is 2. 2 is a prime number as well as even. So it is not an empty set because it is containing one element. X is a natural number less than 5 and greater than 7. So and what is there? So you have to tell that number, natural number, which is less than 5 as well as greater than 7. So there is no such number or natural number. So it is an empty set. Fourth part, Y is the point common to any two parallel lines. So we know that the parallel line does not have any point common to them. So it is an empty set. Now question number 2, which of the following is finite or infinite? You know that the finite set in which we can count the number of elements, and the infinite set is that in which we cannot count the number of elements. So in the first part, the set of the month of the year. So we have 12 months in a year, so it is a finite set. And second part, 1, 2, 3 and so on, so it is a infinite set. Third part, 1, 2, 3 up to 100, so it is a natural number from 1 to 100, so it is a finite set, we can count. The set of positive integer greater than 100, so integer greater than 100 is uncountable, so it is an infinite set. Fifth part, the set of prime number less than 99, so you know the prime number less than 99 which can be counted, so it is a finite set. Similarly, question number 3, state which of the following set is a finite or infinite, it is written in the set builder form like this. The set of a line which is parallel to x-axis. Now to the x-axis we can draw infinite number of lines. So it is an infinite set. The set of the letter of the word English alphabet which is countable. So it is a finite set. In third part, the set of the number which is a multiple of 5. The numbers multiple of 5 are infinite. So it is a infinite set. In question number 3, fourth part, the set of animals living on the earth, we can count them. So because we have the census of the animals also in India as well as in the whole world, we have the census for the human beings. The set of the circle passing through the origin. Now circles passing through the origin, we can draw it infinite like this. We can draw it. Suppose this, so one circle, another circle like this. We can draw infinite circles. So the circle passing through the origin is infinite. In question number 4, 2 sets are given. You have to tell whether they are finite, whether they are equal or not. Now in this set A, we have A, B, C, D, and we have D, C, B, A. The elements are same in both, so they are equal. A, B, C, D. 4, 8, 12, 16. 4, 8, 12 is not there in the, so they are not equal. Now in third part, 2, 4, 6, 8, 10, we have 5 elements in this. In the right, in the set B, it is written in the set builder form. So first of all, convert it into the roster form. X is a positive even integer less than equal to 10. So it is same, 2, 4, 6, 8, even integer less than equal to 10, 2, 4, 6, 8, 10. Fourth part, A, X is a multiple of 10. So 10, 20, 30, 40 and so on. But in set B, we have 10, 15, 20, 25 and 30 and so on. So 15 and 20 are not there, and the multiple of 5 is not will not be there in this set A, so they are not equal. So this is the question number 4. Now in question number 6, from which of the following sets are equal? So you easily tell whether set A is equal to any one another set or not. 2, 4, 8, 12. 2, 4, 8, 12 is not there anywhere. So A is not equal to any set B. 1, 2, 3, 4. 1, 2, 3, 4. So B is equal to set B. Oh, D, sorry. So C is not equal to any set. So -1, -1 and 1, -1. So E and G are equal sets and so on. Now in question number 5, are the following sets equal? But the question given is in the set builder form. So first of all, we'll convert into the roster form and then we can tell whether they are equal or not. So in question number 5, the set A is given as which is equal to 1, 2, and the set B is a set of solution of this quadratic equation. Then you know how to solve this quadratic equation. Solve by factorizing. So you are getting -2 and -3 and -2 are the roots of this quadratic equation. So in the set B, we have the element -3 and -2, and we have 1 and 2. So it means they are not equal to each other. In second part, you first of all convert the set builder form of set A, which is F O L, into roster form, which is F O L W, 4 element in it, and in set B also, which is given that letter of the word wolf. So W O L F, so elements are same of both these two sets. So it means these sets are equal. Now in the third exercise of this is based on the subsets of a set. In question number 1, you have to tell whether the following first set is a subset of the second set or not. Make the correct statement. You have to put the sign of set, subset or not a subset. So 2, 3, 4, and we have 1, 2, 3, 4, 5. All the element of this set belong to this set. So we can say that this set is a subset of this. So this sign will be there. A, B, C, but the element A is not in this. So we can say that this is not a subset of this set. Third part, X is a student of class 11th of your school, and X is a student of your school. So all the student of class 11th also belongs to the student of the school. So therefore we can say that this set is a subset of this. Now in fourth part, X is a circle in the plane, and X is a circle in the plane with the radius 1. Now this circle in the plane, which can be of radius more than 1 also, so it will not be in this set. So we can say that it is not the subset of this set. X is a triangle in the plane, X in the rectangle in the plane. So there is no similarity between these two, triangle and rectangle, though we can say that this is not the subset of this set. This sign will be there. Equilateral triangle in the plane and the triangle in the plane, because all equilateral triangle belongs to the triangle, so we can say that this is a subset of this. X is an even natural number and X is the integer, so all even natural numbers are integers also, so we can say that this is a subset of this set. So this is the question number 1. In question number 2 also, examine which of the following are true or false. So AB is not a subset of BAC. AB is a subset of ABC, but it is given that it is not subset, but this statement is false. AE is a subset of vowel in the English alphabet. In vowels we have A, E, I, O, U. So AE is a subset of this. In the first part, AB is a subset of ABC, but it is given here it is not, so it is false. So 1, 2, 3 is a subset of 1, 2, 1, 3, 5. So all the element of this set not belongs to this. So this is not a subset of this. So this is false. Now A is a subset of ABC with a curly bracket. So it is true. Now see it very carefully. A element with a curly bracket belong to this set ABC, which is false, because belongs means the element should be in this. This will be true if it will be like this: belongs to the set containing the element like this. Then it will be true, because if the belong sign is there, the element should be as it is in the set. So X is the even natural number less than 6, so it is 2, 4, and X is the natural number, divide 36, so 2, 4 divides 36, so all the element of this set are in the set second, so we can say that first is a subset of B. Now in question number 3, see it very carefully. The set A containing the elements, very carefully see it. Set A, we have how many elements? So see it very carefully. Just explain in question number 2 also. The set A is given as 1, 2, 3, 4 with curly bracket and 5. Now see it very carefully. In this set, how many elements we have? 1, 2, 3 and 4, not 5. We have 4 elements, because this is a single element with curly bracket. So in this question number 3, we have many parts, and you have to tell whether they are true or false. Now 1 is belong to the set A, that is true. 1 is a subset of A, this is false. For a subset, for the element should be in the curly bracket. To make it correct, so I have to write like this: is a subset of A, then it is true. Then 2, 3, 4 with a curly bracket is a subset of A. This is false, because this element is coming as it is. Now when the element coming as it is, it should belongs to the set A. To make it true, it will be belongs to like this, A. This is true. Now how we make this true also? It is 3, 4. To make a subset of it, to make a subset of this, we should have one more curly bracket to make it a subset of this. Then it will become true. See it very carefully. Now 5 is a subset of every set, so therefore it is true. 5 belongs to this set. It is false, because this element is not coming as it is in the set. So for the element to belong in it, it should be as it is. And for a subset to be a set, for a subset of a set, it should be in the curly bracket like this. If it is belong, so it should have a single curly bracket. If it is subset, it should have a 2 curly bracket. Then it will be a subset of this. So it is a very good question to have a difference between belongs to and not belongs to. We'll discuss the remaining question in the next lecture. Thank you.